Assalamualaikum warahmatullahi wabarakatuh. My name is Nurfaika binti Nordin. My metric number is 33 DTM Native F1028.
My name is Farha Arina binti Ahmad. My metric number 33 DTM 19F1024.
Starch modification has received considerable scholarly attention in recent years. It has long been a question of great interest in a wide range of fields, especially in food manufacturing. Traditionally, native starch have subscribed to the belief that they can have particular thermal properties and functionality. However, native starch are limited by their specific amylose and amylopectin structure. Some studies have explored that starch can be structurally altered with lipid resulting in the formation of inclusion complex, which improve the psychochemical and functional properties. To date, rice starch treated with lipid has still not yet been comprehensively studied. Hence, this study set out to modify the rice starch to overcome shortcomings associated with native starch. To study the effect of different lipids to rice starch. Second, to evaluate the enhancement of psychochemical properties in the modified rice starch. Third, to compare the psychochemical native rice flour starch with modified rice flour starch.
Two samples were used for starch modification. First sample, 500 gram rice ate with 50 ml canola oil and heated on stove for 720 degrees Celsius for 8 minutes. Second sample, 500 gram rice ate with 50 gram vegetable shortening and heated on stove for 720 degrees Celsius in 8 minutes. Third sample, 500 gram rice without lipid heated on stove for 720 degrees Celsius in 8 minutes. Then all samples of the heated rice were dried in the oven for 3 hours at 550 degrees Celsius. The dried samples were grounded into flour using a large blender. All 3 samples were labeled accordingly. After that, all samples of modified rice flour were sieved to 600 mic size using a sieve machine. All samples of modified rice flour were analyzed using 6 methods of analysis such as swelling power, solubility, fiber content, ash content, moisture content, and viscosity analysis. Rice is obtained randomly from L&L supermarket in Pago, Johor. The type of rice is medium grain length and jasmine brand. Rice is rinsed several times using water to clean from dust or rice lice in the rice. Graduated centrifuge tube, centrifuge, oven, conical flask, funnel, filter paper, aluminium foil, conventional oven, water bath, desiccator, electric oven, hood plate, muffle furnace, and crisp.
Swelling power and solubility were analyzed based on the method of Scotch 1964 with modification. Flour samples 0.1 gram dry basis were weighed in a 50 ml graduated centrifuge tube and added with distilled water. The suspension was heated in a shaking water bath at a desired 3 different temperatures: 55 degrees Celsius, 75 degrees Celsius, and 95 degrees Celsius for 30 minutes. Moisture content, ash content, and fiber content were determined according to the method described by AOAC 2004. Viscosity of the samples were measured based on cases and others 2000.
The data generated from each experiment were analyzed by using the one-way ANOVA. Tukey test was used to determine the significance difference among means for different treatments.
At 75 degrees Celsius, there is a significant difference between samples in which the RCO had a higher swelling power compared to other samples. The same results were observed at a temperature of 95 degrees Celsius in which the modified starch of RV has had the higher swelling power followed by RCO and control. At 75 degrees Celsius, there is significant difference between the samples in which the RCO had the highest solubility compared to other samples, while the controlled native starch show increasing trends of solubility as the temperature increased.
comparison viscosity between three samples, which is the highest viscosity of RCO, was 40.30%. The lowest viscosity of C was 11.83%. Meanwhile, the modified starch of RCO and RVS show increasing in viscosity compared to native starch. This might happen due to water penetrates the interiors of the starch granule, hydrating the linear fragments of amylopectin.
Modified food starch are frequently used by food manufacturers. This versatile ingredient can be used to thicken sauce, control moisture during temperature changes, and improve the texture of mouthfeel of a product. This makes it difficult to substitute a modified food starch in a recipe. Resistant starch, which bases digestive tract relatively undamaged, is involved in a lot of things. It is used to add dietary fiber to a wide range of food. This enables food producers to create delicious products with impressive nutritional profiles.
Starch modification, which lipids can achieve desired functional properties such as texture, appearance, viscosity, and stability. Then, the viscosity effect on the modified starch can act as a thickener in the recipe, making it an effective substitute for corn flour due to the high percentage of viscosity level by rice-aid canola oil and rice-aid with vegetable shortening compared to native starch.